Today we're going to take a look at dividing decimals. Yesterday we represented decimals with models when we were dividing them, and I want you to keep those pictures in your mind. Today we're going to take a look at how to use the partial products algorithm to help us. Estimating is still going to be really important, as is thinking about the situation. I'm going to read this first problem. Marisol sets up a lemonade stand. At the end of the day, she has made $8.75. How many cups of lemonade did she sell? Well, I'm noticing over here that each cup costs, green, costs 25 cents. So I'm going to think back to when yesterday or a few days ago we thought about this situation. And I know I am dividing $8.25 into groups that are 25 cents in size. I want to think about estimating. Is my answer going to be larger than 1 or smaller than 1? And about how many groups of 25 cents am I going to be able to get out of $8.25? So I'm just kind of use common sense. I know there are 4 quarters in $1, and there's about $8. So I'm thinking it's going to be somewhere around, I don't know, 30 cups of lemonade. Let's see if I'm right. Probably between 30 and 40 cups of lemonade. We said that she is trying to decide how much $8.75 is if we divide it into cups of lemonade that cost 25 cents each. I'm going to go ahead and I'm going to use the partial products box method. And we're dealing with 25 hundredths. So and then we're doing 8 and 75 hundredths. I want to get this into hundredths. So I'm going to go ahead and I'm going to do what we discussed the other day, and I'm going to divide without using the decimal point, and then we'll place the decimal point based on our estimate. And I'm going to go ahead and estimate somewhere. I'm going to use some compatible numbers here. I'm going to say that this is probably close to 100 hundredths, and this is going to be close to 25. So I know that I have a basic fact here, 100 divided by 25. So I think my answer is going to be close to 40, which kind of makes sense. So let's start off here. 25. What's the largest number I can multiply 25 by that will get me close to 875? I'm going to think about what it would mean if I did 25 times 4. 25 times 4 would get me to 100, but I've got 800. So I think I might try 30, because I know 3 times 25 is going to give me 75, and then if it's 30 times 75, it's going to give me 750. So if I do that, I'm going to have a 5, 2, and a 1 left over. Okay, now I'm going to think about the biggest number that I can multiply by 25 that will get me close to 125. Well, I know that 4 times 25 equals 100. So that's pretty easy. 4 times 25 is 100, and I'm left with 25 left over, and I know that 1 times 25 is 25. So I've got my 30 plus 4 plus 1. I'm going to add those up, and I get 35 cups, which does make sense. 35 cups of lemonade. James rides his bike 16 and 32/100 miles. He rides about 9 6/10 miles each hour. How many hours does it take him to ride this distance? For this, I kind of want to think about it visually before I even start, just to get an idea of what's happening. So here's James on his cute little bicycle. There's James, hey, I'm riding my bike. And he starts here and he's riding his bike and he rides a total of 16 and 32/100 miles, and then he is really tired because every hour he's riding 9 6/10 miles. So I'm going to be like spreading it up into that many. So I have a visual here. So the expression I'm going to use is what? That's right. 16 and 32/100 miles divided into each hour that he rides 9 6/10 miles. I'm going to estimate. I know that a multiple of 9 that's really close to 16, it's 18, and I know 18 divided by 9 is 2, so I'm thinking he's riding about 2 hours, which doesn't exactly match my model, but I didn't really think about the estimation before I started. So we'll see if that makes sense. Okay, bye-bye, James. I'm going to think that my estimated answer is 2, and my work's over there. Okay, let's take a look, and we'll use our partial products division to figure out how to solve this. I'm going to use my box method here, and I have my dividend, the number that's being divided. It's 16 and 32/100 divided by 9 6/100. So what I did is I turned all of this into hundredths just to make it easy for myself. And then I can place my decimal point based on my estimate, or I can just think about what that means in general. But if I was going to think about it this way, I have to make sure I'm really, really careful about going back to my estimate. So I'm going to think to myself, I've got 96. How many times can I multiply 96 by a number so it's going to get me close to this? Well, 96 is close to 100. And I know that if I did 16 times 100, it would get me pretty darn close. But that's kind of hard to do. So I'm going to just start off with my 10. I know 16 could probably work, but I'm being really lazy today. 10 times 96 is 960. And again, I'm just going to do my partial products. And I could do a little bit more if I felt like being, super productive and doing a long multiplication problem over here, but I'm not going to because I'm being lazy today. And the whole point of partial products is that you can be a little bit lazy and there's nothing wrong with it. So I've got 15, I've got 13, and I've got 6. So I'm left with 672. Again, I think that was 960. So multiplying by 10 is going to be a little bit too much. Let me just try to multiply by 5. That might not be too hard. I could probably do that. I could even use reasoning. I could say, well, 5 times 96 is going to be half of 960, but my brain is tired today, so this is a pretty easy long division. 9 times 5 is 45, and 3 is 48, so I get 480. I'm going to have to regroup, and I get 17 minus 8, which is 9, and I get 192. So I'm going to estimate again, and I'm thinking this time it's going to kind of be a number. I mean, if this is close to 100, I'm going to probably only have to multiply it by 2. So 2 times 96, that was 480 up here. I'm really hopeful that that's going to work out evenly. I think it will. And because I know that 6 times 2 is 12, and 9 times 2 is 18, and 1 is 92. So I'm going to add up all my partial products. 10 and 5 and 2 is 17. But that doesn't quite make sense because my answer was 2 hours. I know he didn't ride for 17 hours. So I was dealing before in tenths. So I'm thinking that this is like 1 7/10 because 1 7/10 is close to 2. Let's see if that works out. Is there a way that we could figure out how to do that? We could always check with multiplication, so why don't we give that a shot? My estimating is always good because it gets tricky with the decimal points when you're doing partial products. So I've got 1 7/10 times 9 6/10. Aren't you happy you learned decimal multiplication? I'm going to set myself up for success. And I know my decimal points, remember how we count them over when we place it? We're going to multiply just like normal. 7 times 6 is 42. 1 times 6 is 6. I've got my 100 too. 0, the hero goes here. Yay! 7 times 9 is 63. 6 up there. 1 times 9 and 9 is 6 is 15. I'm going to add these together. I'm doing just like what I would normally do. Here's what we need to remember. 1, 2. 1, 2. And sure enough, I get 16 32/100. So he rode 1 7/10 hours. Let's do our check for understanding now. A school shirt sells for $8.25. So far, $57.75 has been raised from selling the shirts. How many shirts have been sold? I know that this time my answer is probably going to be a whole number because you can't sell part of a shirt. So I'm going to go ahead and I'm going to do my estimate, and I'm going to say, well, $8.25 is close to $8. 57 goes with 8. 56 kind of goes with 8. So I'm sharing this much money into this many size pieces, my little t-shirts. So I've got $56 divided by $8 a shirt. So I'm going to get somewhere near 7 shirts. Okay, let's go ahead and think about that using our partial products method. I'm going to give myself a little bit more room. I'm going to erase shirts because we know it's shirts. So here's my box method right here, my partial products. I've got 7. Whoops, no, I don't have 7. Haha, I'm getting ahead of myself. I don't have 7. I got to be careful. I'm dividing $57.75 by $8.25. I'm going to do this I'm going to work with the hundredths because I'm dealing with hundredths over here. So I'm kind of imagining pennies, 825 pennies. And over here, $57.75 would be a lot of pennies. It would be like 5,775 pennies. Anyway, let's think of the biggest number that 825 can be multiplied by to give us something close. I'm just going to go with 10 is going to be too big. So let me start with 5. 5s are always easy. For this one, I am going to have to do my multiplication, but 5s are pretty easy. So 5 times 5 is 25. 2 times 5 is 12. 8 times 5 is 41. So I've got 4,125. I'm going to subtract to see what I have left. Okay, I have 1,650. Hey, this looks pretty easy because I'm noticing here I've got an 800 and here I've got a 1,600. 800 times 2 is 1,600. 25 times 2 is 50. So I think I just have to do a 2 here. So let's see. I can go over here, just do my work over here. 825 times 2 is 1,650. So it came out even, 1,650. And I know that I've got 5 and 2 are my partial products. Lo and behold, they sold 7 shirts. Whoops, spelled that wrong. My brain must be fried from multiplying. 7 shirts. Okay. Each mint in a roll has a thickness of 25/100ths of an inch. I'll look at my picture here. Write and solve an equation for how many mints are in the roll. Describe how you solve the problem. I'm going to let you try this one on your own. Take your time, use your paper, solve it, and answer the quiz question. Okay, first, let's go ahead and we're going to estimate. I know that I have 3 5/10 of an inch, and each mint, so I'm thinking that like mints are little pieces in here, is going to be 25/100ths of an inch. So I'm going to estimate. I'm going to think to myself, I know that 4 groups of 25/100ths equal 1. This is 3. I'm going to also look at my basic fact here. Got a 35 and a 25. I could say that this is close to 3/10 and this is close to 40/10, and I could say 40 divided by 3, but that's not a basic fact. I've got to make this close. So what's the number that goes with 3 that's close to 3 5/10? Oh, that's easy. 3 6/10. So I know that I'm probably going to have close to 12 mints. Let's see if that is right. Let's see what you got. Use my partial products, and I've got my 3 5/10, and I've got my 25/100ths. Well, this deals in hundredths, so I'm going to just forget like I have the decimal point here, and I'm going to kind of make this into hundredths as well, because I know that 3 5/10 is the same as 3 50/100ths. And now I can kind of forget about my decimal points because I know that I'm just talking about hundredths. I'm thinking about pennies. I'm imagining if I had stacks of pennies, or in this case, little stacks of pieces of mints. I don't know. So I'm going to think to myself, 25. I know that 4 times 25 is 100. So I'm going to give that a try. 4 times 25 equals 100. So I'm going to put my 100 here, and I'm going to have 250 left. Hey, that's a pretty nice number to work with, because I'm noticing that 250 is like 10 times 25. Okay, so I've got my 10. 10 times 25 is 250, and I don't have anything left. So right here, I have 4 and 10, and so I have 14 mints. So if you answered 14 mints, you were correct. And we just described how we solved the problem. This is the last question we're going to do today, and it is a brain buster. It is a 2-part question. And this 2-part question is super tricky. We're going to have to really do our favorite thing, which is the know and find chart. I'm going to go right here with my facts. Know and find. Okay, here's what I know. Shaniqua uses the ingredients shown in the table to make lemonade. She pours herself a 5/10 cup serving of the lemonade to sample the taste. She then pours the remaining lemonade into 7/500th size cup glasses for her friends. How many glasses can she fill? So there's a lot of things going on in this problem. First of all, she's making lemonade and she has these ingredients. So she has 5 5 cups water, and she has 2 5 cups lemon juice. I think she forgot the sugar. It's going to be not great lemonade. Anyway, so she's going to make a certain amount of lemonade. Then she's going to drink, to test it, 5/10 of a cup. After she drinks 5/10 of a cup, she's going to share what's left with her friends. And her friends get no sugar lemonade in 7/500th size cups. How many cups? Okay, so I want to know how many cups over here. But I have a lot of missing information. So I'm thinking here, if the first thing I want to know is how much does she make in all? Because she has to mix it first. So I'm going to need to probably add. Then I know that she is going to drink this much. So I'm going to have to subtract this from this answer. Okay, and then that's going to tell me what is left, which I'm going to have to divide into 7/500th size cups. Oh my goodness. That's okay though. We can do this. We can do this. So the first step, step 1 is going to be to think about what's actually going on. And this is going to involve order of operations. So when I use order of operations, I'm going to use my parentheses. What's going on first? Well, I've got 5 5/10 cups of water plus 2 5/10 cups of lemon juice. I add those together. And then she drinks 5/10 of a cup. So I've got this amount left over. I'm going to leap ahead to 6th grade. Sometimes if you want to show 2 different things that have to be done first before you do the third thing, you use brackets. So we know about parentheses, but the brackets, I'll make these a little darker so you can see. The brackets say you can't move to the outside until you do all the things inside. Okay, so once you do all these things inside, she's added her lemon juice and water, then she drank this much. She has a certain amount left, which she is going to divide into cups that are 7/500ths of a cup in size. That is a chunka-munka, big chunkus problem, but we can do it. We can use our order of operations to help us. So basically what I'm going to do here is I'm going to go, okay, I'm going to go ahead here. I know 5 5/10 plus 2 5/10 is going to give me 8. Okay, good. I did that. 8 minus, and remember, I've still got my brackets. I did this, but I've still got my brackets. I'm going to rewrite this whole question because I still have to do what's inside these brackets before I can move to the outside. So I know 8 minus 5/10 is going to give me 7 5/10. So I did my brackets here, and now I can get rid of them. I'm going to divide the 7 5/10 cups into sizes that are 75 hundredths. Now, we know already that we can divide by powers of 10 here. So I know that if I'm dividing 7 5/10 by 75 hundredths, I can simply multiply by 10. 10 times 75 hundredths is going to give me 7 5/10. So I know she can make 10 cups of lemonade with no sugar, and her friends probably will never ask her to make lemonade again, and she certainly isn't going to sell it for 25 cents a cup like her friend did. So maybe Shaniqua needs to move on and bake cookies. And that's the end of today's lesson. I hope you enjoyed dividing with decimals.